In the homework from the previous lesson there was an interesting task that I will make for you now. It requires to copy keep code from the start of the function to the ending curly bracket. Copy it and paste it and change it to key down. So the code that we write here is going to be executed when we release the key, and the code that we write here is going to be executed few moments earlier when we start pressing the key. So for example, here I can write my y equals 300, and here I can press my y equals 0. Of course, in order for this to work, all of the other code moving the player should disappear. I had such only one if moving to the down corridor. I didn't finish the other if in the opposite direction, but I hope you did it. Let's now see how we can move the player now. You can see that the player is in the up corridor. I will start pressing a key now, and you can see that the player is in the corridor, in the down corridor, while I'm pressing a key, and when I release it, it goes up. This is one thing that I hope you have tried at home in your homework. I will make one other change. I will delete the code from key down, and I will write totally different value for my y here in the key up code. I will write that I want my y to be 300 minus my y. This is a strange and scary formula that we learned in the previous lesson. It changes the value of a variable to exactly the opposite. If it was 300, it changes to 0. If it was 0, it changes to 300. And now I can see that my corridor is changing with each key up. And this is exactly what I wanted in task 5 from your homework. I will do one more of your homework tasks, and it's the task with the speed of each node. I already have a variable node speed, and I will enter its initial value. It should be something small so that it can increase over time. For example, a good small value is 0. We can reduce node x by node speed and see the difference now. Now we will not move, the computer will not move the node with 10 pixels per update. But where is the node? Let's see what's going on with the node. Node x value is 800. Strange. Perhaps it should be changed now. It changed to 800. Actually, it appears that node x is not changing. This is strange. I said that node x should be decreasing by node speed. And the problem is that node speed is initially 0 and there is no chance to change it. Even if I write here a line of code to increase node speed, this is a good place for such a line. I'm helping you too much now, because this is the hardest line probably about this thing with the speed, and I have written it on exactly the best place for it. It's in the if for resurrecting a node. So if a node reaches the left end of the screen, it will go to the right end and it will increase its speed. But none of this will happen if the initial speed is 0. If the initial speed is 0, we will never reach the left end of the screen. The node will never reach it. If the initial speed is 0, the node will never reach the left end of the screen, and it even will not move. Let's put a little bit bigger initial speed for the node. And we can catch it now. Whoa, it's faster now. Whoa, even bigger speed. I wonder if this is going to be easy for me soon. I think I'm not going to be able to play this crazy game. I'm too old for this game. Okay, this was crazy. I hope you liked it. Perhaps it's a good idea to stop the speed increasing, or in some other way change this code, because pretty soon you will have just a crazy blinking animation and not a game. But instead I want you to do something completely different. I will stop the speed increasing code. I will delete this line, or perhaps put it in a comment. This is something that I want you to learn now. I'm not sure if I want you to write about this in your sheet of paper with all our knowledge, because it's not a new knowledge that we will be able to do. Relax, there will be a new knowledge for today, but writing a comment is not such a new knowledge. When we press double lines like this, we make a line of code to be not executed by the computer. You can see that there are such lines in the code.zip that you downloaded initially, and they say something in human language. Of course, this is not a code the computer can execute, but we can also comment working lines of code, and when they are in command, the computer will not execute them. You can see that the speed is now not changing at all. So now that we stopped the speed increasing, we will do something drastic with our code. We will change the corridor of the node in one more new way. Sadly, I will have to go back to the time when we had more than one line of code. We had big scary if with bigger scary else's. And in the one case, node y was becoming 300, and in the other case it was becoming 0. I will have to remove this epic line of code and instead start thinking about a good condition for these round brackets of if. Let's think of something to check so that the corridor of the node is really interesting. We've made it the opposite of the player, the opposite of the current node corridor, and now we will be able to make it a totally random corridor. It will not care about where was the node, it will not care about where is the player. It will be totally independent. we can write some our formula that we hope has a strange value that is kind of random, or I can teach you the actual way in which you can take a random number from the computer. This thing that I've written is a random number, so it is not able to stay alone here in the round brackets of if. It's not a good thing to place here, because in this place, in the round brackets of if, we have to place just the conditions, something to check. This number is good to be printed, for example, on each mouse up. If on each mouse up I log this number, I will see what kind of results I should expect from Math.random round brackets. And instead, on this place, I will perhaps only place something boring. For example, is 3 less than 5? This of course is going to be true, so always we will execute this code and not this code. But that's not the interesting point. The interesting point is, let's see what Math.random is capable of returning. You can see that I have a lot of strange digits here, and what I'm actually seeing each time I click the mouse is one number. I guess some of you haven't learned about numbers looking like this. If you are in the first grades of school, you only know numbers like 0, 1, 2, 3, 10, 100. But of course there are other numbers, and those numbers that we see when we click the mouse are numbers that are between 0 and 1. So Math.random returns numbers that are between 0 and 1. It's surprising that there are numbers like those. And actually, is it so surprising? You already knew that you can't eat big apple alone. And if you have a friend around you, you can give him half the apple and eat half of the apple yourself. So those numbers are just like the count of apples that you've eaten. They are bigger than 0 but less than 1. So we can compare such numbers to the number half. This is actually quite a good thing to check, because in exactly half of the scenarios this number will be bigger than half, and in the other half of the scenarios it will be less, so we will go to the else of this if. Let's see if we really have random corridors for our node. Well, not. There were 2 in the down corridor, but now in the upper corridor. Is there something wrong? We almost always have down corridor. Not really. I can tell you from now that everything is just fine. There is no idea and no dependency which will be in the next corridor. It's really random, and sometimes there will be a long chains of the same corridor, and sometime we will go to the other corridor. We can see what is going to happen after a lot of resurrections of nodes if we increase the speed. for example like this, and you can see that we really have both corridors. This is our new knowledge for today. I'm not planning to teach you anything more, but I plan to do something epic with our Guitar Hero game. In the beginning, I want you to try everything that I've did to our code. If you haven't done any of your homework, you should try the new controls and the note speed variable. You should really try to make your homeworks. But even if you did all your homework, I want you to try Math.random. And your bigger task for today is to change this game, perhaps even make it in a new folder. Perhaps it's a good idea to extract code.zip in a new folder called Guitar Hero with 3 corridors. I want you to start working. Perhaps first start thinking about what would our game look if we had 3 corridors. How big will be each of these corridors? We only have 600 pixels for our height, so each of those corridors should be 600 divided by 3, meaning 200 pixels, not current 300. You should think of how would our controlling with the mouse or with key up or key, we should try to make all of our controls that we did so far work with a 3 corridor game. And in the beginning, don't try to use Math.random for your 3 corridor game. The last task for today will be to make the notes change their corridor at random. We will first try the other ways the notes change their corridor. For example, go in the corridor that the player isn't. Wait. But there are now 2 corridors that the player isn't in. Perhaps everything will change, but you are still able to think of a really easy way to move the notes without any randoms. Do your best. I think you've learned a lot in the previous lesson, and you will be able to make your own Guitar Hero with 3 corridors. If you don't, in the next video I will help a lot. Good luck!